Hey there, finance friends, welcome back. In this video, we are going to wrap up our time value of money section, and we're going to be looking at the present value of a series. Let's jump into it with some technical jargon, get that out of the way, we'll get our formulas, and then we'll apply our knowledge with a few practice questions, okay? So starting off, in case you've never heard this before, it might be helpful for you to know that the time value of money is probably the single most important concept that you're going to come across in personal finance. I want you to recall, because we're doing in this video the series approach, not the lump sum, recall that an annuity is a series or stream of equal cash flow payments to be either received or paid in the future. You can apply this knowledge for both money that's being drawn out as well as money being drawn in. It doesn't really matter. It's still an equal cash flow. So you'll recall that an annuity is a series or stream of those equal cash flows that are either to be received or paid sometime in the future. You'll also recall that we distinguish between an ordinary annuity and an annuity due. With an ordinary annuity, the cash flow payments or the investments, they occur at the end of the period. With an annuity due, those cash flow payments or the investments, they're going to occur at the beginning of each period. In our discussion right now, we're going to be talking about the present value of a series. The present value of a series. So the present value of a series, aka the present value of an annuity, aka the PVA, if you just want to abbreviate it, this is the current worth, the current value of a stream of payments to be received in the future. The present value of a series, aka the present value of an annuity, aka just the PVA, is the current worth or the current value today of a stream or series of payments to be received in the future. As with all these types of calculations, you can also rethink and rearrange your thinking to get applications. Alternately, you can think of this concept as the amount that you would need to set aside today at a given rate of interest and for a given time period in order to receive some desired stream of future payments. So again, it can be, if I put in a certain amount, what's it worth? It can also be, if I have a certain amount, what can I pull? Okay, so again, the present value of a series is the current worth of a stream of payments to be received in the future. You can turn that on its head and see it as the amount that you would have to set aside today at a given rate of interest and for a certain time period, two big factors, in order to receive or be entitled to some stream of future payments. As always, timelines can help you go from abstract and word and kind of thinking-based problems to actually map it out. In this case, you kind of get the idea now. We have 0, and we're going to have some number of periods in the future, n basically, and ultimately, we're bringing back these series of payments. We're pulling them back. We're pulling them back by our interest rate, and each of them will give us a number, which when summed up, gives us what we're searching for, okay? As always, we can determine these problems with a formula. This one's a nasty one, so let's write it out. Be real careful to get it correct. Let's write this one out. The present value of an annuity is equal to the payment multiplied by 1 minus 1 over 1 plus I to the n divided by I. So again, it's PVA is going to be equal to your payment multiplied by this big hairy thing here, 1 minus 1 divided by 1 plus 1 raised to the n divided by the interest rate. Okay, get that written down, make sure that you get it correct. It's a nasty one, I understand. But fortunately, as you can guess, we have a shortcut here. You can also determine your PVA by multiplying the fixed payment amount, that is the stream of future money paid or received, multiplying the fixed payment amount by the present value interest factor for an annuity number. You can multiply your fixed payment amount by what we call the present value interest factor for an annuity. You can find it in the tables, as you know. We abbreviate this one PVIFA. And once you find that, you can get rid of this big nasty formula and simply go to this. The PVA, the present value of the annuity, is equal to your payment amount multiplied by the present value interest factor for the annuity given your particular interest rate and number of periods. Okay, so that's really what it comes down to. I strongly advise that you get comfortable with the tables because you do not want to be doing this thing all the time. Use the tables, it makes it very easy. A useful application of PVA calculations, there's a couple. PVA calculations can, number one, they can help you estimate how much money you can withdraw from your retirement account fund every year over a specified time period. If you're trying to figure out, can I retire, this PVA calculation, you simply take this equation here, we're going to rearrange it. If you do that, you can estimate how much money you can withdraw from your retirement fund each year over a given time period. And the formula is this. Your annual withdrawal amount, try to spell this correctly, your annual withdrawal amount. And by the way, remember, think about this. The amount that you're pulling out over a period of time, that's basically your payment. So your annual withdrawal amount is going to be equal to the PVA divided by the interest factor given your percent and your time frame. If you have an idea of what your nest egg is, and you also understand your interest rate and your time period, you can rearrange the equation that we had before and determine how much can I pull out periodically in my retirement. That's a good thing to know, okay? Note that you can also use these concepts to do some interesting analysis of investments. A lot of investment analysis is ultimately an opportunity cost decision, and it's rooted, as all things in economics are, with the idea of marginal cost and marginal benefit. You're weighing the cost and benefit. Let's do an analysis with the simple problem. Let's say that lucky you have won the lotto. Great success. You never need school again. You're going to be rich and wealthy. You win the lotto, and your prize is going to be $82,000 annually. You're going to get that for 25, oops, not percent. You're going to get that for 25 years. And you know that if you were to invest it, you could probably generate, you know, because you're a big time guy now, about 9% per year. Okay, so again, you've won the lotto. You're going to be getting a prize of $82,000 annually. You're going to get this prize for 25 years. You know that you can invest that and get 9%. Notice that we've already got now some data. because the $82,000 is your payment, and your N is 25, and your interest is 9%. Now let's suppose that you are approached by a firm, some random firm, and there's many firms that do this. They approach you and they say, hey there, big winner. We heard that you just got this stream of payments. Wouldn't you like your money now? You know, like a J.G. Wentworth ad. They start singing opera to you. Hey, how about I give you a lump sum now, and then I'll take over the ownership of your future stream. You can have the money now. You can invest in and make more money, and they're going to sell you all these things. So let's say that this firm offers you $700,000 for your, basically for the future of, here's what it would be. The firm would offer you $700,000 in exchange for the rights to your future income stream. So question is, do you take it? Is it worth it for you? At first, you might kind of struggle on this, but with some simple calculations, you can answer. Because ultimately, this is a PVA question. So we would say this: the PVA is equal to the payment multiplied by the PVIFA, the present value interest factor for an annuity, at, for you, 9%, which you can get, and 25. Seen another way, it's going to be equal to $82,000, which is your annual payment stream, multiplied by this income factor. If you went to the table, you would see that the PVIFA for 9% and 25 years is equal to 9.823. Putting all this together, you could determine that the value today, the present value today of your future income streams under those terms is $805,486. You would then say, wait a minute, this firm is offering me $700,000 for an asset that is rightfully worth $486, and therefore, with the simple little bit of calculations, you will reject their offer and potentially save yourself a lot of financial pain. So this is a powerful concept. With that said, we've got a couple of questions. Let's practice. If you'd like to pause the video and work them out on your own, you can do that. I'll solve them now, and we can work on them together if you'd like. By the way, for these questions, I am going to default to the table approach because I do not want to deal with that nasty formula. Because if I did that, there's a high chance of error. I'd embarrass myself on video, and you would never see me in the high esteem light that you do right now. Okay, so let's use our shortcuts because they're valuable, and let's solve some questions. Our pal Frank, old Frank, wants to establish a savings fund. He's a good guy because he wants some local community organization to be able to draw some money. That's a nice thing. He wants to set aside kind of like an endowment, as it were, so that this local community group that he appreciates, that they can draw $800 per year for 20 years. He assumes that he can pull 3% per year. Frank's question, how much does he need to deposit right now in order to achieve his very generous and charitable goal? Well, let's first get our terms mapped out. We know that the payment that we're talking about is $800. We know that Frank wants them to pool this for 20 years, that Frank could theoretically get 3% on the money. We know that there's no money now, so if you did a financial calculator calculation, you'd have to include a future value of 0, because eventually, when I say that, sorry, there's no money now, when the money runs out in 20 years, it'll be worth 0, pardon me. The question that we have to ask is, what is the actual money now? And that's what we're solving for. So again, $800 going out for 20 years at 3%. After 20 years, we assume that it will extinguish, so the future value is 0, and we're solving for what's it got to be now. If this still confused you, you would step back and say, let's map this out. So we would have, for example, this timeline. year 0, year 1, year 2, all the way to years 19 and 20. And basically, Frank would like this group to be able to pull $800 per year. How much money does he have to set aside today to make this stream happen? What is his present value annuity? Well, if we crunch the numbers, we say that the present value of an annuity is equal to the payment multiplied by the present value interest factor of an annuity for 3% 20. If you go check out a table, you would find that it's going to be equal to the payment, $800, which we had here, times the interest factor, which would be 14.877. Multiply that through, and we could determine that if our guy Frank could somehow come up today with $11,901.60, he would be able to provide a stream of payments to this charity that he appreciates for the next 20 years. Okay, that's one application. Let's do another one. Our boy Pete. Pete doesn't want to get a real job. He has no career clue. So he does what every undergrad with no career clue does. He convinces his parents to let him go to law school or grad school. So Pete is going to leave LMU and join a 3-year master's degree program. He would like to have $15,000 available every year to cover his expenses, and he can earn 4% on his money. Pete's question to you: how much money does he have to deposit at the beginning of his master's program to generate that stream of $15,000? First things first, let's get our terms out. Let's make sure that we analyze it logically. The payment amount that Pete wants, $15,000 for 3 years. He can earn 4% on the interest. The future value, when his program is done, the funds can be extinguished. That would be 0. And therefore, what we're solving for is how much right now. We could also map this out on a timeline. 0, 1, 2, 3, and 4. Actually, no, pardon me, not 3 and 4. Just 3. 0, 1, 2, and 3. We know that he wants to pull $15,000 a year for 3 years. So we would draw a timeline that pulls back 15 and pulls back 15 and pulls back 15. And we know that we're going to discount this by 4%, 4%, 4%. We take those values here, and when we add them up, that's going to be what we need. Let's solve it through the shortcut of the formula. I'll try to cram it in here. PVA is equal to the payment multiplied by the present value interest factor of an annuity for 4% 3 years. That's going to be equal to the $15,000 that he wants, multiplied by 2.775. That's the factor table that you would find. And if you get that, you would determine $41,625. If Pete is able to put $41,625 into the account at the very beginning of the program, he could safely draw $15,000 a year and have no problem. Okay? Final question. Your parents, who never had the benefit of taking this thrilling course, they need your help. They have worked their asses off, and they have built up a retirement fund of $425,000, and they're now ready to retire. They can earn 6% per year on their money, and they expect to live in retirement, I hate to say it, but until their death, about 25 years. The question they're going to ask you: how much can they withdraw annually over those 25 years such that they do not run out of money and be forced to live on cat food? Okay, this is an important question, all joking aside, because you do not want to outlive your money. That's not good. So having the appropriate draw in order to spread it out correctly is an essential financial decision. Let's first map it out, get our terms down. Your parents, we already know what money they have. So we already know the PVA, it's $425,000. We know the interest is 6%. We know the N is 25. We know that the future value would be assumed to be 0. I only put this here again, the future value part, because if you're using a financial calculator, you have to enter that variable. The question that they're trying to ask, how big is the payment? How big is the payment? Well, we can take our knowledge and rearrange our formulas, and we would know that the PVA is equal to the payment times the PVIFA. So we would say that for your parents, $425,000 is equal to the payment multiplied by the PVIFA for 6%, 25. We can also kind of rearrange this to basically say that their annual withdrawal, which again is a payment, so their annual withdrawal is going to be equal to the PVA divided by the interest factor for the annuity at 6%, 25, which would be equal to $425,000, which we already knew, divided by the factor, if you looked it up, would be 12.783. This implies that your parents could safely pull out $33,247.28 annually over the course of their retirement without outliving their money. Okay, so simple tool, really, really applicable to lots of situations. One of your challenges will be not just to understand the tool and the formula, but to also have the mental flexibility, the fluidity to be able to say, hey, here's a problem that's ultimately a flow problem. Pick out this formula and apply it to solve your question. Okay? With this said, my friends, we now know what the time value of money is. We know that there are lump sums and annuities, present values and future values. We've now analyzed all 4 situations. And at this point, you've done enough practice problems, I hope, to have a good grasp of it. We can talk about it in live time Zoom if you'd like, but for now, congratulations on wrapping up time value of money. Thanks for your time, and I'll see you soon.